Hi, my name is Jamie Marsh, and today I will be talking to you about the effects on female reproductive systems caused by the use of phthalate-containing medical devices. So today I will be discussing what are phthalates, what do they do, and why do we use them, and then phthalates as an endocrine disruptor. I'll then go into the daily exposures to phthalates, where are these phthalates found, and what are their levels of exposure. I'll then travel into the exposure to phthalates through medical devices. What medical devices contain phthalates, and what are their levels of exposure, especially during a procedure? I'll then go into the effects, specifically on the effects of the fetus when exposed to phthalates during pregnancy. I'll also go into the effects of phthalates on the female reproductive system, specifically looking at estradiol levels and that mechanism of action and follicle genesis. I'll then talk about what's the big deal, why does this matter to us, and why should we care? I'll conclude with a data gap and a conclusion. So, a phthalate, or a phthalate ester, is a large group of man-made synthetic chemicals with a large and varying industrial use. These are commonly used as plasticizers that increase flexibility as well as durability in their products. These phthalates display endocrine-disrupting characteristics that alter normal hormone functioning. A common phthalate is called di-2-ethylhexylphthalate, abbreviated DEHP, and di-N-butylphthalate, DBP. These phthalates, such as DEHP, display estrogenic properties that ultimately cause potentially harmful effects on the female reproductive system and ultimately is the reason why they are called endocrine disruptors. Unfortunately, we are surrounded by phthalates. They're in skin cream, lotion, detergent, shampoo, conditioner, body wash, soap. They're in car parts, clothing, electronics, water bottles, wallpaper, furniture, adhesives. They're in baby toys. They're essentially in any other household products that you could probably think of, anything that's plastic, and everything that has a fragrance to it. In this experiment by Parla et al., 337 women during a 3 to 36-month follow-up appointment after pregnancy provided spot urine samples and answered questions regarding their use of 13 personal care products that contain phthalates. According to this figure, approximately 50% of the women reported using 5 to 8 personal care products that contain phthalates daily. During the same experiment, the researchers then took the number of personal care products and compared it to their level of phthalate metabolites in their urine samples. As you can see, there is a slight trend that suggests that the more phthalate-containing personal care products an individual uses, the higher their phthalate metabolite levels would be. Because phthalates are a commonly used plasticizer that allows things to be flexible but still durable, it is commonly used in polyvinyl chloride medical devices. Some of those devices include IV bags, blood and respiratory tubing, feeding tubes, catheter dialysis tubing and devices, heart bypass tubing, and ECMO devices. Here is a table the FDA published as a safety assessment of DEHP released from PVC medical devices. On the left-hand column, you can see the specific procedure, and in the right-hand column, you can see the DEHP dose, both of an adult and a neonate would be exposed to. As an example, I will use the infusion of a crystalloid IV solution, which is just a normal saline IV. If an adult weighing approximately 70 kilograms, approximately 154 pounds, gets an IV when they go to the emergency room, they would be exposed to 0.005 milligrams per kilograms per day. However, if it's a neonate getting the saline IV, they would be exposed to 0.03 milligrams per kilograms per day. To put that in perspective, the average daily level of dose exposure for a woman approximately weighing 168 pounds is about 0.029 milligrams per kilograms per day. For a neonate, that's an extremely high level of phthalate exposure. So far I've talked about the levels of exposure to phthalates, but not so much the effects. The study done by Shiota et al. In 1982 exposed pregnant mice to varying levels of either DEHP or DBP. It is important for me to start by pointing out the phthalate dose percentage and what they mean in terms of humans. At a 1.0% dose, it is 2,200 milligrams per kilograms per day. However, these dosage resembles the weight of a mouse, not a human. When compared to an average female's weight, the phthalate dosage is actually 0.55 milligrams per kilograms per day, So these numbers suddenly just become a lot more relevant and more realistic. Now I will talk about the graph. Starting on the left is the phthalate the pregnant mouse was exposed to, then the dose of the phthalate the mouse received, the number of litters, the number of implants, and the percentage of the resorptions and fetal deaths. What I really want to point out is that at a high level of DEHP and DBP, it was statistically significant in the percentage of fetal resorptions and deaths. This ultimately allows us to conclude there is a dose-dependent relationship, and at higher doses we see increased number of fetuses not surviving. This is another table from the same paper that displays the effects of phthalates that occur in fetuses that survive the pregnancy. One specific line I would like to point out is the DEHP 0.2% dose, which would expose mice to 410 milligrams per kilograms per day, but humans at 0.104 milligrams per kilograms per day. At these lower levels of phthalate exposure, the number of malformed fetuses are statistically significant. Some of the malformations seen include club feet, fetuses being born with their brains or intestines outside of their body, and severe forms of spina bifida. So I talked a little bit about the effects of fetal exposure to phthalates, so now I'm going to switch gears a little bit and talk about the effects on specifically the female reproductive system. In a study done by Davis B.J. et al. In 1994, mice were treated with 1,000 milligrams per kilograms per day for 8 to 9 days. That is a human equivalent dose for the average woman of 0.253 milligrams per kilograms per day. Now, from this figure, we can gather that the mice exposed to DEHP and DBP showed a statistically significant decrease in estradiol levels caused by toxicity in the ovary. In Part A, we see a significant decrease in estradiol production, and it was insufficient to cause an LH surge, which ultimately triggers ovulation. However, when stimulated with an LH-like compound, ovulation was able to occur, which ultimately allows us to conclude that DEHP was the primary cause of toxicity in the ovaries. This is the proposed mechanism of phthalates on estradiol levels. The first step is MEHP or DEHP starts by acting on the membrane to inhibit FSH from binding by activating an inhibitory G protein. Because FSH would otherwise stimulate cyclic AMP production, MEHP or DEHP decreases cyclic AMP production. As MEHP and DEHP diffuse across the membrane and into the cell, it activates peroxisome proliferator activated receptors, PPARs, specifically PPAR alpha and PPAR gamma. The activation of PPAR alpha and PPAR gamma decreases aromatase transcription in the granulosa cells. Aromatase converts androgens from the theca cells into estradiol. By decreasing aromatase production, we thereby decrease the production of estradiol. Also, when PPAR alpha and PPAR gamma are activated, it increases mRNA for fatty acid binding proteins in granulosa cells. This ultimately causes more binding proteins to be made for PPAR activators and also is another reason why estradiol levels decrease. In another experiment done by Hannon et al. In 2001, adult mice were exposed to varying DEHP doses of 20 micrograms per kilograms per day to 500 milligrams per kilograms per day for 10 days. Folliculogenesis is the maturation of ovarian follicles. When follicles in the ovaries can no longer respond to hormonal changes, it ultimately means there has been a decrease in the number of follicles and indicates the beginning of menopause. As you can see by the graph, when adult mice were treated with 200 milligrams per kilograms per day and 500 milligrams per kilograms per day, the total number of follicles was significantly decreased. Again, it is important to note the human equivalencies for the average woman, 0.0507 milligrams per kilograms per day and 0.127 milligrams per kilograms per day, respectively. Any disruption in normal folliculogenesis can cause infertility, premature ovarian failure, and advanced reproductive aging. So what's the big deal? Why does this matter? Well, I stated the human equivalencies of phthalate doses for a reason, because on a daily basis, we are exposed to those doses of phthalates extremely close to those equivalencies. And there's some pretty serious effects that have the potential to cause some horrible defects, not just to a female's reproductive system, but a male's reproductive system and I know you're probably not thinking of this, but also the reproduction and development of your future children. Also, the government is aware of these potential effects and have even put out a public health notification back in 2002. But is that enough? Should laws and regulations be stricter? Should phthalates even be permitted for use anymore, especially in medical devices? So it's important to also point out that there are alternatives for some of these devices, specifically phthalate-free devices, and they can be used as a substitute in medical situations. However, there are drawbacks to using those materials, and that's a huge reason why there needs to be more research in this area. So we know the products that contain phthalates, and there have been plenty of studies on the effects of phthalates, and we know that medical devices contain phthalates. However, there seems to be a gap in data here. We need a better understanding on the exact mechanism of action of these phthalates, and we also need to address the direct effects of phthalates found in medical devices. And then we need to apply laws and regulations limiting the use of phthalate products, especially in medical devices. So if you're wondering what you can do to limit your phthalate exposure, there are several things you can do. Just be more aware of the number of personal care products you are using daily. And you can also find phthalate-free personal care products that you can use as a substitute. And definitely don't ever microwave plastic containers. And just in general, limit your phthalate exposure, especially during pregnancy. And realize that what we put in our bodies today can have unforeseen effects down the road. So that's it for now. If you have any questions, feel free to ask, or you can visit my website at jamiemarsh.wordpress.com. Thank you.